Welcome to a new test and teardown video. This time it's a Philips System Multimeter. So it's not just a normal multimeter. Type number is PM2535. It's 6.5 digit. So it's 3 million counts. I really hope it works. I was very lucky to get this one in a little trade deal with some of my other instruments. And you can do temperature with a special probe for that. I don't have that. I only got the normal banana leads, of course. Well, this one can do 4 lead, or they call it 4 wire ohm, or 2 wire ohm, of course, and all the usual kind of stuff. Only 3 amp maximum. But the cool thing and very special thing about this Philips is its built-in IEEE interface. So with that, you can of course control the instrument. But there's another bus called System 21. So that is I believe, serial protocol bus where you can connect to other System 21 instruments, and using the IEEE interface you can address other instruments and get the readings from all the other instruments back via one IEEE interface. So that, I think, is the sexy thing about these instruments. So it is more like a main control entry to your test system or whatever kind of stuff you're doing with IEEE, and using PCs and automatic measuring setups. And of course the on-off switch is located here at the rear. That is a little bit annoying for a bench multimeter where you would like to have it maybe installed in your bench setup. So I kind of prefer to have an on-off switch at the front, but you quickly learn where to reach in and operate the on-off switch, so it's not that bad. So I think we're gonna power it up and see if it works. First I apply mains and then I double check there is no power consumption, and then let's okay, so that's it. Overload Celsius, so that is the default. Let's go volts, millivolts. Oi, oi, oi. That is a lot of digits in millivolts. So what are we doing? Mega ohms. And 4 wire. Okay, so 4 wire only goes to kilo ohms. Milliamp. What is? Speed. That is of course the readout speed. And we got filters, external or internal triggers, and you can also range. Oh, let's go to the volts again. So we are in millivolts. Up. Some more up. Hello, why don't you work? What am I doing wrong here? Aha, so that is what we do. So speed changes also. And this is the slowest speed, takes forever. Okay. I don't understand how to do the ranges. I don't really get any kind of range program, and maybe that is the problem. I need to figure out the shift. We got 2 different shifts. So that is the blue. Well, how do I make the blue shift? Maybe I'm just too dumb to figure this out. Yes, I was truly too dumb to figure this out. Of course, it goes into auto mode to begin with, right? And in auto mode, it's not responding to the up-down for ranging, which is a little bit stupid. Why don't you just go out of auto range and then change the ranges if you hit up and down? So I think that is a little bit stupid. But what you need to do is you need to actively go out of auto range. Then you can change the ranges to this and that many volts. Or you can go down to millivolts and whatnot, right? Okay, so that is how it works. And now we know it is probably not that difficult to figure out. Okay, goody goody. I think I got something wrong here because I was reading in the manual about its specifications and how it was doing this and that, and it said something about 3 million counts, but that is not possible. I can't do that, can I? Or has it something to do with the speed settings? So let's try and change the different speed settings. Ah, now I am there. Okay, we got the 3 million counts. Maybe the light here is a problem. Yes. It is always difficult with those LCD screens here. I don't think. Yes, it is 3 million counts. I just found my good old voltage reference. And while it's warming up and while this unit is warming up, of course, we just have to... Oh man, this is nice. We have to wait a little bit and then I will always also warm up another instrument, and then we can compare how is this performing. So I'm still in the warm-up, so that is of course why we see this difference here of 0.3 millivolt, and I'm trying to figure out what kind of readout I can get, because it was supposed to do 3 million counts. And if I crank up the input a little bit, just to see if I can fool it to read C, it can actually read a value that is more than 3 million counts. So let's crank up the next digit and see, yes, see, I can do this. Let's take the next one. Oops, and then I lost a digit. And there we go. So there is a funny thing about its maximum readout. So it's probably very soon here. It's not that important, it's just funny to know that it can actually do a little bit more than the 3 million counts. Where are we? Yes, there we are. Anyway, I will let them run for an hour and then I'll play some more. Up here I'm using the longest possible filter and the longest average of phases. So that will be 100 mains line averages, and I also have a filter, and that is why I was able to add another digit, by the way. Normally this meter don't have that many digits. It's actually looking like this. But you can go and enable another digit if you're a little bit smart, but just adding math and then multiply by 10, and then it will do this little trick here. The next voltage range is a 30 volt range. So in this range I only get 5 decimals after 9 or after 10, right? So you can of course imagine that it would do 30 volts and then 5 decimals, right? But it's very low in this range. Really, that is definitely something I need to play around with. In fact, I want to double check all the different ranges and see what's going on here. So I think it's time that we open it and have a look. It should have been from about 1990, but I'll look at the different ICs and I see 85 and 84 and so on. So that will be the System 21. Probably this is also doing some IEEE kind of stuff. IEEE is just really super simple interfaced with some 8-bit data and some simple addressing and stuff like that. So it's not hugely complicated. So here's a little 6 megahertz crystal for that part of the interface, and the 8031 CPU here is I think that is a 4 megahertz crystal or something like that. I can't really read it. Got an EEPROM and battery backed up RAM, and it says something about cal down here. So there's probably something, calibration is probably done in software. So I need to go and find a calibration procedure and see if I can figure that out. What have we got in those fancy smancy metal boxes? Oh yeah, see, this interface IC was replaced. Good for safety here around the transformer so we don't get an electric shock, so that is good. And the transformer isn't really warm. I've been running with this for quite a long time now, and because I wanted to see if it would change after it got from cold to hot, and I really didn't see any huge difference. Got a little bit of wires and a little bit of modifications going on here around the CPU and a few digital signals. Yeah, but I think we could probably remove those two and get in. That was one of those intelligent level testings. So we got this metal shield here, and if you note all these little locking flappities here, right, and they go through the holes here, right, all those holes. And if you take a little note, the hole is also full of the back. So they actually interlock. So that means, see, you need to figure out which one you decide to take out first and then push it all the way, and then you can pull out one. And I picked this one first because the other one didn't really seems to be able to go away. That was very, very difficult. It goes stick in here and you cannot get out, and then it hits the bottom side, and what the heck is going on here, man? But finally I made it, and then I can now, I hope. Why can't I do that? This one must, of course, go this way, right? But it is that good a tight fit. Why don't you want to go out, man? Because there's one little, see, right there. And this one decided to play difficult. Okay, so we are out. Oh, will I ever be able to get this in again? Well, I am a little bit impressed. Look at all that electronics. Got another little crystal here, so that is probably a dual slope, and some interface parts for some really nice parts. We got relays, and what is that? Probably some sort of a special relay or something like that, right? I haven't yet figured that out. High precision parts and tons of read relays. And yeah, see, the optical isolated interface for all the digital noisy stuff that will also connect to the readout. The only thing I'm a little bit sad about is that we don't have any backlight on the LCD. That could be so nice. That will make my day. But other than that, it's a nice instrument. Once I figure out what is going on here, that'll be the current ranges, current protection, relay for 4-wire modes. See, and there's another fuse here. So if you give it too much current, then you need to figure out how to get in here in the very difficult compartment, I must say. And then we have another connector here at the back, and I don't know what that one is doing. Oh, you gotta see, there's a little super nice detail I have to show you. Look at that. So they use the space under the fuse to put a little IC, and that's probably the line driver for the System 21. Maybe it's just an RS485 or 422 bus or something like that. I haven't really looked into it yet, but it looks a little bit like that. Oh man. Yeah. 85, 83. So maybe my model here is a little bit older. I was hoping for 1990, but was an 85 or 86 or something. Yep. So that is what it is. I'm not too happy about this lithium battery for calibrations and stuff. Maybe I should measure the voltage. Maybe that could explain why it's so bad. Remember earlier in this video I complained about how accurate it was and what can you do about it. So I found in the manual how to calibrate instructions, and they're probably not super clear, so I will try and repeat it just to show you how it works. Let me see if I can get you some of the digits right. Of course you're supposed to do this after a long time, a long warm-up time, and also of course you want all the metal shields, as you can see here in the back. My metal shields, they're still out, so I want to remount all the metal shields and the case and everything, let it run, let it settle, and then perform all the calibrations once again, just to show you what's going on. So at the moment I got about 30 volts positive input to both of my meters here. So what you want to do is you want to hit cal and then reset and then release reset while you're holding in cal. So of course when it wakes up after a reset, it is that cal that it's detecting. So now it is in calibration. So to activate a calibration, there is this shift and check. So shift check is what you need to do. So now it says something about cal. Now you need to hit function, which one of the functions it is you want to calibrate. I want to do volts. And see, it starts in the 300 volt range, so that is important. Then I go down. Now I am in the 30 volt range, and I now input exactly 30 volts. You got three options in this 30 volt range. You can either input 0, positive 30, or negative 30. It will auto detect which one of the three things you're doing, but at the moment I'm just doing positive. So when you are ready with the positive, then you simply hit single trick. So here is single trick, and then it's gonna perform a lot of average and stuff. Oh, and you can even see that my input is a little bit low now, so I should have adjusted my input to be exactly right. But now it has stored a value that is a little bit too low as the correct input for 30. But you get the point, right? So now I will shift check to store that calibration and then continue to the next calibration. So then I take my two inputs and then I short my two inputs to give you 0, of course, right? So, and then you just do the same. You single trick, and then it will now store the 0. Come on, come on, come on. It takes a little while, but otherwise you have to skip this part if calibration is not super important for you. And then it should say something about this R is the important when it has done it. And then, okay, shift check. Now we're ready to perform the next one. And now we go negative. So now it's negative 30 volts. And then when I am sure that I have the negative, so I have a lot of average, as you can see here. I should probably adjust my input a little bit up just for the fun of it, but it doesn't really, yeah, I could do that. Give it a little bit more here. And let's see in a minute if I got the right minus 30. That is some of the things when you're running a long average time to get a very good stable reading. But I think it was, yeah, you see, I am running on the last digit here, so I can easily click it up 2 more clicks on the last digit. But of course, this is not super important for the example here, what I want to do. And then, okay, single trick the negative 30. And then we should see how that worked out. Of course, after the last calibration here of negative 30, then you have again to store the right value by doing shift check. But I'm waiting for this R. See, here we go. So that was the R, and then shift check. So now I'm done. I've stored those 3 values and I can hit reset. So now the unit is reset. We go back to voltage function, and of course it starts in the 300 volts range. So I have to go into manual mode and 30 volt range. And as you can see now, we have a very good reading of minus 30 volts. And I can of course go short the inputs, and I should have a very good 0, and I can go positive. So that should definitely make this instrument work if you're doing the calibration. And if, of course, if you want one more digit, you can hit the speed 1. It says here speed 1, and that means it's giving you one more digit after some time, like that, right? But again, I will now mount all my shields, and then I will perform all those calibrations again. Oh, what we could do is we could try 10 volts. And if you scroll back in the video and see earlier in the video where I measured 10 volts, I think you will see that it has improved a little bit. And of course I did calibrate this a little bit wrong. And again, missing shills. And oh yeah, by the way, I need also to add the filter to get a more stable readout. So I just wanted to say thank you very much for watching. Hope to see you again tomorrow. Bye bye.